we are talking all things Spring AI, and we are basically going to talk about how we can establish a integration from our Spring application into, say, OpenAI or ChatGPT, as commonly known. So we want to see how we can utilize Spring AI in our microservices architecture. So this is another cup of code, and I'll be showcasing this endpoint right here that we'll be creating, and essentially see how we can get ChatGPT or OpenAI rather to assist us in getting some FAQs and assist your space with a knowledge base, basically that is focused and centralized around your particular space. Say if you're in corporate and you want to share information about the company, about certain processes, about certain policies, rules and regulations, you can basically allow API engine, or create an API, an AI engine rather, with Spring Boot, and basically just allow users to prompt the particular API that you have, and they can basically get some feedback and responses based on what your AI tool will assist with. So in this tutorial, we do have the project set up in our repository. So if you are interested in pulling the code base and utilizing that on your side, please do pull the project in zip code OpenAI microservice, and you'll basically be able to use that. But other than that, let's start with the project and see how how to set it up and basically get it running. So first things first, we always start on the Spring initializer, and we will basically have a Maven project that is obviously Java based, and the Spring Boot version 3.3.5. I always recommend take the latest stable. That will basically suffice for what you're trying to achieve, and also you'll have long-term support, which is always recommended. So project metadata, we have the group, which is com.zip code, and we have the artifact OpenAI microservice. So this is just a demo project for Spring Boot, and the packaging is jar. The Java version is 17, always latest stable version. Long-time support, latest stable version is basically a recommendation for all your dependencies. So moving right along to the dependency side, Spring Boot DevTools, we need this for live reload. When we change our code on the fly, we won't need to restart the server ourselves. We will just bounce on its own. And then we have Lombok, which is basically boilerplate code for some of the access modifiers and things like that. So it just allows us to have that annotation for shorthand boilerplate code. And then we have Spring Web. Obviously, we'll be scaffolding an API, so we will need Spring Web available so that we can have our controllers. And OpenAI, which is the AI tool that we'll be integrating with and communicating with. We'll be sending all our queries, prompts to OpenAI, and then OpenAI ChatGPT will then feedback or give us a response based on what we query. So let's get right into the code and see how that looks like on our IDE. So these configurations are available in the application.yaml. So please go to that file. If you pull the code from Git, you'll be able to find the this configuration, and just you push that to the browser, and you should be good to go. So let's bounce into our Spring Tool suite, and you will see first things first is the application.yaml, and you have the Spring application name, which is basically OpenAI microservice, and then we have an AI OpenAI config, and then we have the API key. This API key, I'll show you now where you can get it, and then we have the chat base URL. The chat base URL is chat completions, and from the chat completions, basically we will get our payload from there. So that's essentially how we basically set up the connection to ChatGPT. And to get the API key, you would have to come to platform.openai.com, and you can basically set up an account here. By default, you will have a free tier account, which in my case, I couldn't transact on the free tier account, so it kept on throwing my quota exceeded, so I couldn't do anything. But I had to increase my limit, so I just added $5. You can convert that to your local currency if you're not using dollars. But in my case, I had to pay like the first level above the free tier, which was $5 for me. Then I paid that, and you can see the usage and consumption over here. So depending on your requirement or your need, you can basically increase the limit to whatever tier that you want. And then once you have that, you can basically come to API keys. And then in API keys, you can create a new secret key, just like that. And you can name the key, let's say YouTube, let's say YouTube demo, let's say maybe GPT key, something like that. So you can name it something like that, and default project depending on the project that you have. In my case, I just use the default project, so that's fine. But if you have a different one, you can just add that. And then you can basically allow all permissions, or you can restrict which permissions you want to give to that particular key, so that or whatever transactions that they do, they only can transact to what you've allowed them to transact in. And you can see that different models that you can hit. So to view the models, you go to that endpoint, and basically in the model capabilities, you can see that we have V1 audio, we have chat completions, we have embeddings, we have images, we have moderations. So there's a whole lot more that you can do. But in our project, let's go back to application. You will see that we're just doing a chat completion. So we just want text. We are just interested in text, nothing fancy there. It is a tutorial, so we're just showing you how to set it up, and then based on your use case, you can then use the model capabilities that you want. Obviously, you can call more of these, and then on assistants, you can basically call the assistants there, and the model is required for assistants, and basically threads if you want to see the threads. And then you can also see the fine-tuning over there. So all of these configurations, based on the feedback of this tutorial, I can do more of this if you are interested, so that we can spend more time exploring all of the capabilities that we have available to us. So please do feedback, please do comment on the comment section. Please do like and subscribe, guys. I really appreciate it. It goes a long way to motivate, and also gives us that energy to do more, do better, and improve. Please do comment on the audio feedback, and also the video, the audio quality, sorry, and the video quality as well. So please do feedback on those. Let us know if everything is looking good, so that we can always improve on the quality that we deliver. So that being said, let's jump back into our code. So now that we've seen what we can do and which endpoints we can hit on OpenAI platform, we are able to then start transacting using our API key and our base URL that we want to hit. And once that is set up, we're going to start from application main class. So we're going to go application is Java. You can see it's just a normal Java class. We are, however, adding a bean REST template, which is what we're going to be using to hit the OpenAI endpoint. So we're going to make a REST call to OpenAI with our parameters and a prompt, and then OpenAI is going to feedback with the response, and we can essentially consume that and basically send it back to our user or our consumer. So the next thing is the chat controller. So if you look at the chat controller, it's a REST controller, and that REST controller has a request mapping of intelligent, and intelligent has a dependency injection. That dependency injection is a zip code AI service, and that particular service we're going to look into now. And we have one get mapping, which is chat with the prompt that we want. So if you go to our Postman, you will see that we have intelligent and we have chat, and then we have a path variable which is explain Spring Boot, Now that it has explained Spring Boot, we are basically getting the response over there. So we got this response. So Spring Boot is a framework for building, packaging, and deploying standalone Spring-based application. It simplifies the development process by providing a set of tools and conventions to quickly create production-ready applications. So that's just what ChatGPT gave back to us, and we can feed back to our users or to our consumers, and basically to enhance the knowledge base in our space, to enhance, let's say, FAQs. And because we are doing this in our own microservice, our own API, we have more control of how we want to control the prompts that can go in. Say a prompt or a query can come in as, let's say, about accounting. It needs to have accounting related questions, something like that, in a sense. And then you can basically filter those and validate that is this prompt aligned to what is acceptable to our space, so that not so that you don't allow people to just ask whatever they want to ask in a space that is not applicable. So you're talking, let's say maybe a finance space, and someone is asking you about tire pressure and something like that, which has nothing to do with finance, financial services, if we were to put it that way. So you would then have more control here, because this is within your space, and you can control how you validate prompts and questions in a nutshell. So, and you can see that our endpoint basically has a response entity of 200, which is okay, and that's a map of the generation, which is this field that you see here, this generation. And then we have AI service.chat, and we pass in the prompt. So now let's jump into AI service and see what that guy looks like. So our service is zip code AI service, and it basically has the API key, and it also takes in the API base URL from the application properties that we saw just now. So after that, we just have one dependency injection of our REST template, which is already a bean that we saw on our main class. This REST template is available, and then on the service side, let's go here. And the service side, we just auto wire that into the service. So now that we have the REST template available, then we have our method that actually handles the chat. So we take in the prompt, and we basically set up the HTTP headers, and we pass in the application JSON, and we pass in the bearer token. So the bearer token is our token from our config, which we got from OpenAI. And then once we have this header set, we then build our object, and our body object is a model of GPT 3.5 Turbo, and the messages that we want to pass is role, user, content, and the prompt. So then this is how we basically query OpenAI, and it will feed back with the response that we expect. So once we've built our request payload, and we then pass that into an HTTP entity with the body and the headers. So once the HTTP entity is set up, we then pass that into our REST template post for entity. So this is a post request, and you can see that we have the API URL, we have the entity, which is the body and the headers that we've set, and then we have the generation class as a response type. So this is in our domain. We'll see just now. So we'll see how the generation class looks like, and we basically expect a response entity of generation type. So once that comes back, once the response comes back, we check if it's a success. If it is, then we just want to get the response. .get body, get choices, .get the first one, and get message, and get a content. So we get the content from that object, and once the content is back, we send it as a string back to our user. Otherwise, we just throw a runtime exception, OpenAI call failed, response status code is basically that. So if we get a failure, we'll just throw it back as a runtime exception. And we have just released a add controller advice. So in this scenario, if you haven't seen that tutorial, please do watch it to see how you can maintain and manage exceptions that are thrown by controllers. So when this is thrown in our controller, we can throw the very same exception, and then it will be handled by our control advice, and it will have a proper feedback to the user rather than just a runtime exception. So something like that. Please do watch that video of control advice. That is very, very handy when it comes to throwing back messages to users. So, and that's basically about it here. So now let's look at the domain generation class. So if you go to generation class, you can see that it's basically a Pojo with a list, one field of a list of chat choices. And then if you go to chat choices, you will see that chat choices is a Pojo that has chat message, and chat message is a Pojo that has string content. So this is the setup of how OpenAI typically has the models or has the payload coming back. But I'm taking what I need. Obviously, there's more into the payload, but in this case, I only need the string content, and that's basically what I'm making use of. So there's a chat message that has string content, and that content will come back to, or that chat message will come to chat choices, and then chat choices will come to the generation object, and that object will have a list of choices, and that list of choices, we just get the first one here from the response. We get the first one, and we say get the message and get the content and feedback to the user. So in the same way that we have it here in our Postman, this is basically the content that was sent back from ChatGPT or OpenAI. So if I change the prompt, for example, let's say maybe explain Java, and then send. Let's see. Java is a high-level object-oriented programming language that was developed by Sun Microservice in the mid-1990s. So you can see that we are getting feedback from our controller, and let's say maybe explain Swift, for example, and then you send that, and we basically await our feedback, and it will tell you Swift is a powerful, intuitive programming language developed by Apple for iOS, macOS, watchOS, and tvOS app development. So all of the prompts are coming in, going to ChatGPT, and we get the response back from ChatGPT and feedback to our users. So now we can see that we're able to integrate with OpenAI, ChatGPT, and get responses based on the prompts that users have. And like I mentioned earlier, because now this is in our space, the microservice is controlled by us, we can control what goes in as the prompts or validate them before we send them to ChatGPT, so that we don't have prompts that are out of scope of what we're trying to achieve or what we're trying to solve for. So that's essentially about it for now. If you want more on ChatGPT and Spring Boot, please do comment down below, and we will basically respond to you and create the tutorial accordingly. But for now, until next time, cheers.